Hello everyone, my name is Ann Purvis and I'm one of the leaders of the Toronto Field Naturalist Juniors program. Thank you for all the great contributions to the slideshow this week. It was also wonderful to have everyone at the third nature class that meets on Wednesdays at 4:30. Others are welcome to join and we'd be delighted to see any new faces. So this week we're going to start out by looking at this collage of nature journaling entries Sandra sent in. We started out our journaling about sumac, and you can see the beautiful drawings that Alexi, Sienna, and Sandra have made. Also, I would like to say that you can take photos of your artwork from this week, from your leaf collages, or anything you nature journal during the week, and send that in along with your photos to go in the slideshow for next week. Something I have loved about our nature discoveries is when several people send in pictures of the same thing that they've seen in different parts of Toronto that same week. If it is a season for a creature to do a particular behavior, then it is quite likely that a number of us will see it, and that's been a very exciting discovery. So I challenged the group today in these photos of river water to see if they could spot any creatures. And of course we saw the duck right away, but over here on the right we can see a very large fish swimming, and I believe there's some examples of that over here as well. And I see Amara watching the fish in this picture. So what are these very large fish doing in the Toronto rivers? These are adult female salmon. When they are about 5 to 6 years old, they look for the exact stream they were born in, and they travel up that stream in September or October to lay their eggs. So that salmon run is going on right now. No one knows how they find the stream they were born in. It could be by smell or by magnetism. When the female has found a good spot, she will dig a shallow depression with her tail and lay her eggs. Then she covers them with gravel. So Amara and Pamela were privileged to see one of these egg deposits. The fry hatch out in the spring. They actually feed in the river on invertebrates for a couple of years before returning to Lake Ontario, where they become full grown. There is a TRCA movie about this on the blog post. It also explained that there is a program to reintroduce native salmon to the Toronto rivers. These were wiped out by European settlement, pollution, dam building, etc. But we would like to get our native salmon, the Atlantic salmon, back. And that program is underway at the moment. Karina and Sebastian also saw this great blue heron at Morningside Park in Highland Creek. I was curious about whether these birds migrate or not. It turns out that some do stick around southwestern Ontario, sort of in the area of Niagara Falls where the water is fast moving and they can continue to fish. Others overwinter in the US, and some spend the winter in Mexico. So they do mostly disappear from most parts of Ontario. Tyler, Bryn, and Tora sent in this picture of spindle galls, and I challenged the group if anyone remembered which creature makes these very strange skinny galls. And I was pleased that several people in the group knew that they were made by mites, these tiny little 8-legged creatures that are so small they can live in the pores of our skin. I also challenged the group. We've seen praying mantises several times in our slideshows. If anyone could tell us whether this is a male or a female. I believe Alexi and Sonia both knew that this is a female with a swollen abdomen. So she's going to lay her eggs in a foamy mass, and then she's going to die. That will be the end of her life, and the next generation of praying mantises are going to come from the eggs that she has laid. Sandra, Alexi, and Sienna sent in this photo of a hickory tussock moth, caterpillar, which we also saw last week. This one, however, is in leaf litter, and I challenged the group as to what it would be doing in leaf litter. I was very pleased that several people knew that the tussock moth caterpillar feeds on the leaves of hardwood trees, and when it's mature, it drops to the ground and builds its cocoon in the leaf litter under the tree. And it actually spends the winter in that state as a pupa, and it will emerge in spring as an adult. Amara found this woolly bear caterpillar. There used to be a myth that the width of this stripe on the woolly bear caterpillars was a prediction of whether it would be a hard winter or an easy winter. As it turns out, the caterpillar sheds its skin several times during the summer, and each instar, we call these instars, each instar of the caterpillar, this brown band gets wider. So it's not really a prediction of the upcoming season at all. The woolly bear is famous because it is one of our caterpillars that freezes solid to spend the winter. So this woolly bear is probably ready to go into that state of suspended animation. We were recognizing in the group that we could not freeze solid. So this creature has a way of protecting its cells. Often these creatures that freeze solid create proteins in the space between the cells, and that draws the water out of the cells so that it doesn't freeze and expand and destroy the cells. So this is probably one of the strategies of the woolly bear. In the spring, the woolly bear will thaw out, pupate, and turn into an Isabella tiger moth. We sometimes see woolly bears migrating in great numbers across roads, and there's a mystery around this because woolly bears are very versatile in what they eat, so it isn't clear why they are on the move. So last week we had a picture of a parasitoid wasp, a Megarhissa wasp, in our slideshow, and we learned about the amazing life cycle of it laying its eggs on the larva of another wasp, of a horntail wasp, deep inside a piece of wood. We might think that only wasps are parasitoid, that a cute little bumblebee like this wearing a furry coat and looking so cute, it would never be a parasite or parasitize other bees. That is actually not true. This is the lemon cuckoo bee, and it follows the trail of worker bees, of Eastern common bumblebee, back to their hive, which is in the ground. The Eastern common bumblebee is a true social bee, which means that there's a queen and then there's workers who do all the looking after of the young. And it will actually hang out. It will try to figure out whether it can actually attack the hive or not. And if it does, if it decides it can handle it, it will enter the hive. It will kill the queen, the eggs, and the larva of the Eastern common bumblebee. And then it will rub itself against the workers to take on the scent of that hive. And so that the workers will actually cooperate with this queen. And then those workers will look after her eggs when they hatch into larvae and feed them. So we were having a discussion, Karina and I, about this drilling of this wood, which was very aggressive. And we were questioning whether it would be a porcupine or a pileated woodpecker. My take on it is that it might be the work of these kind of teeth marks here, look like they might be the work of a porcupine. Porcupines go after the cambium layer, which is right under the bark, and that is how they get all their nutrition. It's very, very full of fiber, so they have a very long 25-meter gut in order to digest that wood. But they don't rip apart a tree like this, taking off huge hunks of wood. And so I'm guessing that this is the work of a pileated woodpecker, because they are going after wasp larvae, beetle larvae, which is much deeper in the wood. So these two white funguses here on the left were contributed by Sandra and Alexi. And I challenged the group if they recognized what type of fungus they were. People did know that this was a puffball, and when a drop of rain hits the puffball, this spot in the middle opens and pollen puffs out. This one on the left is bracket fungus, and it's actually furry to the feel on top. It's in the Trametes group. Pamela and Amara photographed this gorgeous bracket fungus over here, which looks like it's been treated in some fancy fashion, and it's actually called the lacquered fungus. So it has little white pores, 5 or 6 per millimeter on the bottom side that give off its spores. So in this photo, we asked if people could recognize what was being photographed here, and people found this bird. And it has a white throat. It's the white-throated sparrow, so it's one of our early migrants in the spring, and clearly one of our last migrants to leave. And it's obvious why that would be the same group of birds, because they can adapt to a diet where there aren't that many insects around. So we think this is a ruby-crowned kinglet juvenile, because it has the beginnings of wing bars here and an incomplete eye ring, and very olive. I had wondered if it might be an orange-crowned warbler because of the yellow under the tail, but we saw some other photos where it didn't look as yellow under the tail, so we're pretty sure it's a ruby-crowned kinglet. So this would be a juvenile. This would be on its first migratory flight, and when it comes back next spring, it will have the brilliant red crown and very pronounced wing bars, and it will be heading up to the boreal forest to nest. And we have robin here. We know now that some robins are spending the winter in Toronto, so we're not quite sure whether this is one that's going to migrate or not. And finally, this is the Eastern Cottontail rabbit. He's so cute and incredibly well camouflaged. So Eastern Cottontails are becoming much more common. They are a solitary rabbit, actually. They don't live in a warren at all. They build a nest out just by hollowing out a circle of grass, and their offspring are quite helpless at the beginning. So they have to look after them for quite a while, stay with them and look after them. This rabbit is nocturnal and solitary, but it's a tasty meal for quite a few predators like coyotes and birds of prey and so on. It has a very high reproductive rate, which helps to compensate for that. So I think it has 2 litters a year at least, and quite a few rabbits in each litter, sort of 8 or 9.